طيب, بسم الله الرحمن الرحيم. So last time we talked about this slide and we said that the network components are divided into three major categories. Of course, we have devices, and by devices here we mean any type of device, whether it's an end device or a network device. I kind of confused you when I said that the media means the content. The media doesn't mean the content. The media here means the cables and the type of medium that we use for communication. Okay, so media here does not mean content like multimedia. Like media here means the cable or the type of cable that we use for communication. And the services, which is the software that runs on any device in the network, whether it's a router or a switch or an end device or applications and so on. So this is the general components of a network, how a network is composed of. We'll talk about each one. As we said, devices here are divided into end devices, and end device, they provide the interface between the user and the network. So end devices, these are what we use as users to communicate. Whether this is like a workstation, laptop, printer, VoIP printer, like Cisco IP telephone that we use, security cameras, anything. So these are the end devices, which are the interface between the user and the network. And we have network devices. The network devices here are the intermediate devices that facilitate the communication. Whether it's for local area network, we commonly use switches, hubs, and so on. We use access points. Or to connect different local area networks together, we use routers. Or, as we said last time, we use dedicated hardware for firewalls. So these are different network devices which facilitate the communication. Okay, media. That's what we mean by media. So media here is just whether you use wire or wireless. Okay, and this is the physical medium that we use to connect devices together, whether it's end devices or network devices. As we will discuss later in more details, the media are divided into three major categories. We have copper medium, which means that we have wires, okay, and inside these wires we have copper. An example of this is what?
The usual connection that we have. It's the usual connection we have right now.
Yes, the cables that we use for Ethernet connectivity. Even telephone lines are some type of copper cable. What else? TV cables, coaxial cables that we use to connect to the antenna. In fact, we use these coaxial cables as well for network. Okay, so these are some examples. Fiber optics, of course, fiber optics, they don't use copper. In that case, they use what? Glasses. Okay, they use glass material. Not glasses, glass material, okay? And typically, fiber optics, they support very high speeds. And we'll talk about the different characteristics of fibers versus copper and how each of them actually works. The fact that it supports very high speed makes it attractive to provide very high speed communication. Not only that, you can support it through very long distance as well, which is good. However, it has some drawbacks as well, and that's why we're not using this, for example, for Ethernet. Yeah, so there are some characteristics in the fiber optics that makes it very attractive in certain types of networks, but not in others. Okay? And of course, we have the medium, which is no medium, which is wireless. So we use the air to communicate. Of course, in that case, you need some type of antenna to... so we'll talk about, no, the radio waves it's not the only type of, so there are different types. Yeah, all of them, they use electromagnetic waves in some way. So these are the type of media that we have in general. The network representations is very, very important because we're going to be using these symbols from now on in the course. And by by just looking at the symbol, we should be able to figure out what we're talking about, and consequently, what technologies that are typically used in this type of network. So, for example, the end devices here, we have symbols like a workstation, laptop, telephone, printers, and stuff. So these symbols are for end devices. So we can use these symbols at any point in time to indicate that this is an end device. This is a device that's used by a user to communicate through the network. More importantly, these are the symbols for a network device. So, for example, if we have an antenna like this, we mean a wireless LAN or wireless communication. This symbol actually represents the switch, and switch is used typically to connect multiple machines over on a local area network. So it's used to connect between different nodes in a local area network. So that's what I said. So once you look at the symbol, you should be able to tell so many things. You should be able to tell that this is a LAN. And consequently, it uses a specific type of technology, which is like Ethernet 802.3 or something like that. We'll talk about this. Okay? This is the symbol of a router. And router typically is used to terminate LANs, and it's used to enter network multiple LANs together in the form of a WAN, or wide area network. We'll talk about that. Multi-layer switch. Multi-layer switch is a special type of switch that has some network functions. We'll talk about this later on. Or dedicated firewall, which is not, we're not going to be using this symbol very frequently.
The multi-layer switch also controls the LAN?
Yes, it's used inside the LAN, but it has like layer 3. We'll talk about, when we talk about layers, we'll figure out what this means. Okay, so as we said, this is the end devices, intermediate devices, and network medium. So network medium symbols are very, very important as well. So for example, this symbol represents wireless, whether this wireless is wireless LAN, wireless cellular communication or something. So this symbol means wireless. Means that we're not using wires, basically. This black line represents usually LAN media, or it's not like LAN media per se, because we will see that we can use this in some other types of networks, but this actually indicates copper medium that's commonly used to connect workstation to a switch or something like that. So what this would represent a copper cable in general. Or this red line, it also means a copper cable, but it's typically used to connect two routers together in a point-to-point fashion. Okay? So these two symbols, they indicate wires or copper cables, but one of them is commonly used to connect workstations to switches or hubs, which is basically UTP, or the one that we actually commonly use in our laptops to connect to Ethernet and so on. But this red line, we don't see it as users typically. This is used to connect routers together inside the network. Okay? So this commonly refers to a LAN, which means we use Ethernet technology, for example. Versus this represents a WAN, which, again, commonly, not always, which typically uses point-to-point technology, or PPP technology. We'll talk about these technologies. But both of them, they indicate copper cable. Okay? Okay, so the form of how you connect devices to each other through cables, okay, is what we call a topology. So a topology refers to how the devices are connected together. Okay? A topology can be a physical topology or a logical topology. We'll talk about the difference between these two definitions. So a switch, if you connect, for example, multiple machines to a switch like this, okay? So this means a star topology, a physical star topology. But we will talk about, when we talk about logical topology, we will actually realize that this is equivalent to this. So it's typically a bus. It's a shared thing between multiple machines, okay? But in any case, a topology is just a way for us to represent the connectivity between the devices together using the cables, okay? So when this connectivity has a certain formation, we call this as like a star topology. We call this as a mesh topology. A mesh topology, basically, you have multiple devices like this, and each one of them is connected to all the others. So you have something like this. Mesh means that everyone is connected to everyone. So that's a topology. Okay. Thank you. So we have different types of networks. As we mentioned last time, we have LANs and WANs. And when we talk about LANs and WANs, we mean the representation of the network from the geographical sense, which means that LANs refer to local area network, which is represented by multiple nodes that are geographically close to each other. Typically a lab or مثلا a group of labs and or a floor or in a building and stuff like that. A LAN is usually terminated by a router port. So if you have machines like this connected using a switch, okay, that's a LAN. If this switch is connected to a router, if this switch is connected to another switch, which is connected to other machines, so we call this a LAN.
And to connect every local area, we need a router.
Yes, so once we connect this switch to a router, okay, and we connect this router to anything else, so we know that this is not, the whole thing is not actually a LAN. It's, this part is a LAN and the other part is a LAN, and what's in between is actually the interconnectivity between the two LANs. So how we mark the termination of a LAN is once we see a router port. Once we see a router port, we know that what's on the left is actually a LAN. Okay? So typically routers, they are used to connect multiple LANs together in a large geographical area. In a large geographical area. So, oh yes, this one. Okay, so the metropolitan area network is something in between. Metropolitan area network, it's a type of a network that covers reasonably, or مثلا a building or مثلا two buildings together. Okay, so usually we refer مثلا to QU network as metropolitan area network, and the termination of a MAN is a service provider, which means that QU has a metropolitan area network that's connected to Ooredoo. Okay, so metropolitan area network is somewhere between the LAN and the WAN. Okay, so a MAN can actually include some routers, which happens at QU. In QU, we have infrastructure that connects different LANs together using routers and stuff. And then from QU, in order to connect to the internet, we need some service from who? From Ooredoo. Okay? So in that case, we typically call the QU network metropolitan area network, although this term is not very commonly used. So we usually have LANs and WANs. So you will not find the term man used very often. Sorry? Personal area network. Personal area network. That talks about a network for a person. And this is a very recent term that's used to typically connect multiple wireless devices together. Like, for example, if you have iWatch with your cell phone, with another Bluetooth device and things like that, we call this a personal area network. And it's not like a LAN. Local area network is actually personal, which means that it's very, very short range. Very short range. And typically this type of networks, they use wireless technologies. Okay, so we have also wireless, which is a LAN that uses wireless technology, basically. So when you talk about access points like this and different workstations or laptops connected to this access point, we call this a wireless LAN. And you have a storage area network. Storage area network is a network that's used to host content, okay? And because this content is extremely large, we cannot host it on one device. So we host it on different devices, and we connect all these devices together as one unit. Okay, like for example, YouTube. YouTube, in a way, of course, YouTube is not just a storage area network because it has a lot more than that. But they have servers, different servers that host different content, right? And for you as a user, YouTube is just a server, right? So you connect to YouTube as one entity, but they store different contents on different machines or different workstations or servers. So they need some network connectivity between these servers together, and that's what we mean by a storage area network. So a network that connects multiple devices, and each of these devices, they host some content. So the main purpose of this network is just storing content. Okay, that's what we mean.
So it's a connection between servers?
It's a connection between servers, that's true. But typically, the connectivity between these servers, they kind of unite all these servers as one unit. So for us, we actually very commonly connect on the storage area network as one entity. It has like one IP address and we connect to it. And you don't care where this content is, whether it's on this server, on this server, on this server, you don't care, right? So connecting all these devices that each of them host some content will make them as if they are one unit. And we can fetch the content from the storage area network as one unit. And we don't care where this content actually is. Any other?
Is it fast enough to make all devices work as one unit?
Yes, using special type of network infrastructure, it makes it very fast. Yeah, for example, we talked about fiber optics. So if you connect all these servers using fiber optics, okay, then you make the connectivity between them extremely fast. So they look to you like they are one entity. However, fiber optics has some limitation. They have special types of routers, and it's not easy to design. Of course, for YouTube and these big elephants, it's a piece of cake. But it's possible. From the technology point of view, it's possible. Okay. So that's how the LAN looks like. So we have typically a switch, and the switch connects multiple devices together. So which type of topology is this? We call it star topology. Everyone is connected to a center node. It's a star topology. If this is connected to another switch here, that's still a LAN. If this switch is a router, then this is a LAN. So we can specify the boundary of the LAN by just looking at the symbols. Okay? That's why we said that symbols are very important. Because by looking at the symbol, you'll be able to figure out where is the boundary of a LAN, where is the boundary of the WAN, and so on.
Switch, you mean the device?
network device. A switch is a network device which uses Ethernet. They are using UTP cables to connect between the devices. So this is a physical topology that represents a star topology. Okay. Any other questions? So that's the WAN. A WAN is an interconnection or internetwork between multiple LANs. So this is a LAN, this is a LAN, and by interconnecting them together using typically point-to-point connection like this, we call this a WAN. Using routers. So once we see a router, we know that this is the termination of this LAN. That's a router. This is the termination of another LAN. We see two routers connected together. This is a WAN.
The WAN is only between router 1 and router 2. It does not include both lines in it?
No, the WAN is just everything. Okay.
Everything together. Both
Yes. Everything together is just a WAN. But this is the WAN medium. This is the connectivity that makes this a WAN.
When we connect our devices to routers, are we actually connecting to switches or actually routers? What are
It depends. You can connect a workstation directly to a router. In which case, your host or your laptop connecting to the router, this is a LAN. Okay? Even if it doesn't have a switch. But in that case, go ahead.
Routers usually do have switches. In fact, some of them have them. Most routers actually have switches, but some of them can allow you to fully change the operating mode.
We're jumping ahead here. There is a difference between a router and a switch. We'll talk about this difference in details, in great details later on. But for now, we just need to know that when we see a router, this is a termination of a LAN. That basically, from this router on, we have to use IP. So a router uses IP. But inside these LANs, we don't use IP for communication. We'll talk about this.
The
Yeah.
Wi-Fi device itself.
Wi-Fi?
The Wi-Fi device itself is a router, right?
The Wi-Fi device at home is a router. Yes.
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 So Origo has like this device on the wall, a black device. You don't touch it. It's there.
Right.
From it, you connect it to a
We'll get to that because this is jumping way ahead. We're going one step at a time. What you're talking about is a very complicated technology, okay, which we will get to very soon. Okay? But typically we just connect the devices using switches, and actually in the near past we used to use hubs as well, which is a dumb device that does not exist anymore. It's obsolete almost. But we used to use it. And then we connect to routers to terminate this LAN. And then later on we will talk about the different technologies, how we can connect to a service provider. This is coming in a minute. So because, as we said, this is a WAN, but not very often, but sometimes we call like a network like a QU network that's composed of multiple routers. We call it a metropolitan area network. Okay. Once we connect to a service provider, we call this a large WAN. Okay, so if you want to distinguish between MAN and WAN, MAN is limited by a network that's connected to a service provider. Although this is not commonly used, at least in this course, this term is not commonly used. So now, how do we connect to a service provider? Through different technologies, like what you have just mentioned. We'll talk about this in the next
The connection itself between, like the Wi-Fi device and whatever the phone, the computer, is this considered a LAN? I think it is.
Is this what?
Like the Wi-Fi device itself
Right.
to, let's say, your phone
Right.
and computer.
Right.
Is this considered is a
A LAN, yes, a LAN, yes.
So basically, the Wi-Fi in home,
Uh-huh.
from user to Wi-Fi device is
Right,
a LAN.
is a LAN, yes.
But after that is
Right, right. Well, if you want to get to the details of this, the wireless communication itself uses some kind of physical address. So you don't use IP until you get outside of the access point. Okay? So the access point can connect multiple devices together, and they connect to each other or communicate to each other using special type of address. From the access point to the service provider or to the core network, you have to use IP. So this is a little bit confusing because here the device contains switch from one side and router on the other side. And it's as if you have combined a switch and a router together. That's why we said we are jumping ahead and we need to talk about this one step at a time. So when we talk about Ethernet technology and the network access layer, we will realize that inside a LAN you use some kind of a physical address for communication and things like that. And then when we get to a router, we have to use IP. That's when we go up in the stack. So we didn't actually talk about what stack is and what are the layers of communication and stuff. So when you get to this, you will be able to understand this more. It depends on what technology you use in each one. Typically, the Ethernet or the LAN speeds are higher, right? Because you can connect all the devices using cables, and these cables typically have high speed. But the WAN connectivity or the point-to-point usually connects two routers which are far. Except if you use here like some kind of fiber optics, in which case the fiber optics is like very high speed, and in that case the WAN speeds will be much higher. It can actually aggregate traffic from millions of LANs very easily. So it depends. The answer to your question is it depends on the technology used in each one. For example, you can use here Ethernet, which has very high speed, but here you can use wireless cellular message. Okay, so here is slower than here. So it depends. Okay. The ultimate WAN, of course, is the internet. Okay, so again, the internet talks about the internetworking of many millions of LANs together. But this can contain some broadband communication links which connects some of these routers to service providers through special technologies which we will talk about. Okay, so this is from the geographical sense, from the geographical point of view. We talked about local area networks and wide area networks, and in between we talked about metropolitan area network. Intranet, it does not talk about geographical aspect here. By intranet, we mean it's a group of devices which, in many cases, geographically distributed across the world. However, they form together a logical, not physical, a logical network that's totally isolated from the other networks. What does that mean? This means that we can simply have multiple workstations like this, and they are connected to a switch. So that's a LAN, right? This is connected to a router, and this connects to another switch, which connects multiple machines together. Okay, so that's a LAN, and this is a WAN, okay? If we say that these workstations, they form an intranet, this means that these machines are geographically distributed across multiple LANs. However, they logically form one network which is isolated from all the other workstations, which means that if this machine communicates with this machine, all these other devices will not be able to listen to how they communicate or what they communicate. And we typically use technologies like VPN. So VPN creates private communication between these devices, even on the same physical network. So on the same physical network, there is data going back and forth, but if you are not part of this intranet, you will not be able to listen to what they communicate. So they use special technologies like VPN for this, which includes encryption of data and things like this. Through routers, switches, everything. So the physical connectivity of the network includes all these devices, but the machines that are part of this intranet are totally isolated isolated in terms of what they communicate from all the other devices on the internet. And this is used as a very common example. Just imagine مثلا Microsoft or Apple. Right? They don't have all the machines exist in the same geographical location. You can imagine that they have branches all over the world, right? So they have many, many machines that exist in different locations. And as you might imagine, there's no way for these machines, when they communicate, that we listen to what they communicate, right? It doesn't make sense. In which case, the Apple network, even though it's distributed in a different geographical locations, but they need to have private communication that's totally isolated from the internet. So Apple has an intranet. So an intranet is usually owned by one organization or one entity. And this entity is distributed across multiple geographical locations. So that's not a LAN or a WAN in that case. This is a logical definition of a network that exists on the physical internet network, but it's logically isolated. It's private. Yeah, it's private. It's private. There's no point. Imagine just yourself getting into the intranet of Apple. It's a disaster. They need to have confidential communication. And that's why the people who work in these companies, they usually have like keys and some special devices that they always have with them, that when they get to the laptop, they connect to the intranet through VPN. It asks them about certain keys, and then they put the key. It's very secure. Once they do this, they connect to the intranet, which allows them to get into specific servers and things like that, which anyone else cannot see. Okay? Even though these servers are connected on the physical network that we all use, but they are very, very secure and very isolated. Okay? So intranet is usually owned by one organization. So what is extranet? Well, extranet is the internetworking of multiple intranets, basically. So each intranet is owned by one organization, but both intranets, they need to communicate together as well. Like, for example, as you can imagine, Apple communicates with Microsoft in a way. So they have specific type of application, a specific type of communication. That communication needs to be secure as well, needs to be private. So there are some servers in Apple, okay, that of course Microsoft cannot see, but they have extranet that allows exchange of special type of information, which as well need to be private. So when you have extranet, it's the internetworking of multiple intranets. Each of these intranets are owned by one organization. Okay? Any confusion? So there is LAN and WAN and MAN and things like this, which uses the geographical sense. And there is intranet and extranet, which it's not limited by a specific geographical location, but it's a logical connection between servers that makes this network isolated from the internet. Okay? Okay, so as we said, we as users, in order to connect on the internet, we need to have connectivity to a service provider. Or maybe QU as a business or organization, it needs to connect to the internet through a service provider. So for this, we use special type of technologies. For users, here we're talking about users. For users, we use some of these technologies like dial-up. I'm not sure if any of you lived on the days of, but there are, believe it or not, there are still some countries that support dial-up. Okay, so we use our phone line to connect to the server. We dial a certain number and we get to that. We put user all days, but it still exists in some countries.
They completely shut down what we have.
هنا in Qatar طبعا, of course.
It's all now.
Yeah, but still exists. Yeah, as a technology. We also used to have satellites. It was not very common, but some companies, they offer internet service through satellites. So you can connect through satellite and get to the internet. Of course, here we support lower speeds and stuff, but it used to exist before. Of course, with the proliferation of cellular technologies and DSL or ADSL, and now we have the luxury of fiber to home and things like this. Of course, all these technologies have disappeared.
What is the difference between satellite and cellular? Because Ooredoo uses satellite.
It does use satellite in صح.
So when I get internet from Ooredoo,
Mm-hmm. You don't really know what technology you use once you get to Ooredoo. يعني we get to Ooredoo through fiber. Inside the Ooredoo network, because Ooredoo has very sophisticated infrastructure. Inside this infrastructure, they could have cellular. Okay, they could have cellular. They could have satellite. They could have any other technology. We don't know, but we connect to Ooredoo either through ADSL or through fiber to home. So this is the interface between the user and the Ooredoo. Inside the infrastructure of Ooredoo, they could be using many other technologies. But what I'm talking about here is that the satellite communication or the cellular network is actually the interface directly between the user and the service provider. An example of this is our cell phone, right? So our cell phone basically uses cellular network as the interface to get the service from Ooredoo. And whether we use voice calls or we use it for data communication, we directly use it for the cellular technology.
The fiber technology has two versions of it.
The what?
Fiber has basically two versions of it. It's the same thing.
Right.
One of them is when you go to a new area that doesn't have any connections and fiber has been installed.
Mm-hmm.
It is a pure fiber connection, so it's super fast and you get the true speeds.
Right.
Now, if you go to some of the older areas, like where I live, they either don't have the money to do it or it requires basically breaking into the house.
Okay.
So they can't do this. What they do is they take the outside wire on the street, they exchange it to fiber. And what you get is basically cable, not fiber.
Right. So, yeah.
But the speed from them to the cable is fiber. What you get is like a little bit better than cable.
Right. So what we're saying here is that we could be using cable to connect to the service provider network, which in the core network they could be using fiber, they could be using cellular, they could be using satellite or whatever. Okay? So for us, the interface to the service provider is a cable. Or the situation that we have in our houses right now is that the interface to the service provider is directly through a fiber. That's the situation that we have. Okay? When we talk about the speeds and plans and stuff like that, that's characterized by not only the medium that you use, but also the technology that you use on top of this medium. We will talk about that. Okay? I think that we're jumping back and forth, but it's okay. So when we talk about speeds, you could be using fiber to home, but on 1 megabits per second. It still exists. So the technology allows you to communicate using 1 megabits per second, even through fiber. But fiber itself can potentially support very, very high data rates. If you use the proper technology and you get the right plan from the service provider, you can get even hundreds of gigabits per second. But depending on the technology that you use and depending on the plan that you use, which makes you pay a certain amount of money. So it's a group of factors that dictates how you connect to a service provider and what speed you use when you communicate through a service provider. But these are some of the technologies used. For businesses, as you can imagine, you see like technologies like dial-up and things like this will become really not feasible. So very commonly they use satellite communication. They use, of course not nowadays, except in certain locations where you cannot have dedicated like submarine cables, for example. So you cannot connect to another country except if you use satellite. Okay, so it depends. ADSL, there are some technologies on ADSL that supports very high speed, so it's feasible to some business, especially small business. Dedicated lines are very much common. So QU has dedicated lines when it connects to Ooredoo, of course, and dedicated lines or leased lines, they can support very high speed. And usually these lines we use by fiber optics or something like this to connect. However, the setting up of this type of dedicated lines is not easy. Okay. So network as a platform. So from here we need to discuss very interesting issues that, well, some of them are historical. Like for example, the networks in the past used to be designed for a specific purpose. Like for example, landline networks. We use our landlines at home to make phone calls. That's a network because it connects to specific switches that Ooredoo or Vodafone مثلا has, and they have infrastructure that switches your calls and make it happen. This is a network which is used for a particular purpose, which is مثلا voice calls. We also have some network like cable TV network. Maybe Qatar did not have cable TV in the beginning, but in many countries in North America, they used to have cable TV network, in which case you don't actually use satellite for TV. You connect to a cable TV network at home through which you get the TV. Even before Ooredoo offers Mosaic or anything like this, but in the past, in Canada and United States, for example, they have cable TV network, which is solely used for TV. It's not used to communicate data. They use special type of cables to connect to a network that gets them the signal for TV. That's a network which is established for TV. Okay? Another network which is only for data communication, which is what we have, like Wi-Fi, like Ethernet, and so on. We use these types of network for data communication. In the past, these three types of networks were kind of, separate. They are in a way separate. Each one of them, they use certain infrastructure with certain technologies to facilitate the communication of a specific type of information, whether it's voice calls, TV, or data, and stuff like that, right? This concept is disappearing now. Okay? Now we have the concept of converged networks. Converged networks talks about the same network infrastructure being used for all these applications all at once, for all these types of information. So Ooredoo network uses the same infrastructure to allow you to make voice calls or to make data communication through the same infrastructure. So they have inside their infrastructure specific technologies, specific hardware that allows this network to be used for all these types of information all at once. So what is the benefit for them? What do you think is the benefit for them?
Well, having 3 or 4 or 5 different types of networks and their dedicated devices is just not efficient.
Okay.
One, and very expensive to keep up,
Right.
servicing it, keeping it properly working. And in the end, these old technologies are very not that accepting of the high numbers of people.
So it's not efficient. So having separate infrastructure for a specific type of information is not efficient. It's cost from the cost point of view, right? But if I can have the same infrastructure supporting multiple diverse type of services and applications, then this is very cost effective, and I can support potentially thousands of users with the same infrastructure, which means more revenue, less cost. That's perfect.
That also allows them to have like what happened with Zion,
Right.
like special packages for
Right.
people where you get
Right.
to be in.
But that requires careful design and packaging of technologies inside this network, which allows you to give different plans and for different types of applications, for different users and businesses and things like this. So you can imagine the level of heterogeneity and granularity that they should support in their network. So the network supports tons of applications, even different types of users. We have businesses, we have users, we have big companies, we have small companies. So each of them, they have different needs. Each of them, they have a demand for different services. So how can I have one single infrastructure that supports all these diverse requirements, needs, applications, things like that? It's not easy. And that's the trend, because it's very cost effective for service providers to have this concept, converged networks. And not only that, when they expand the network, everybody will benefit. So when they expand their infrastructure, all of these users will enjoy better services all at once. Rather than, again, if I expand the telephone network, then I can have more telephone lines, but data is the same. So.
Yeah. Also, back to the master stands.
Oh, okay.